Hey, what's going on, folks? It's Mike here, and welcome back to my deep programming language series. In today's episode, we're going to continue talking about object-oriented programming with classes, and this time talking about inheritance. Now, we visited inheritance, this topic, before when talking about super, for instance, in our episode on constructors, so you can check back the playlist and take a look at that. And again, I'd recommend checking out the other previous videos on classes if you haven't already. But with that said, let's go ahead and dive to the deep programming language website and check out some information about classes. And I'm going to go ahead and just go to documentation here, the language reference, and let's just go ahead and explore what there is in relation to inheritance here. So I'm going to go to classes here, and let's just go ahead and search for our keyword inheritance. As you can see, we have a few results popping up at the top. And again, a reminder that when we're talking about classes in the deep programming language, we do make that distinguishment versus structs in that we allow inheritance in classes. So again, structs, very simple value data type. Classes, a reference-based data type. Again, we've covered that in previous videos. And because it's a reference type, we can, it enables inheritance rather, and makes it easy for us to do things like polymorphism. And again, we're going to see how that works with inheritance here. Okay, so again, let's just go ahead and take a little peek here at a few different things here. And I mean, this is the basics here with this little example here that says, well, all classes inherit from a superclass. We'll touch on that in a moment here, this object sort of superclass from which all classes inherit from. So I'm just going to go ahead and open that up here. But this is the basic syntax here for inheritance here, where we create some class and then we create a new type, class B here, that inherits or is derived from its superclass A here. Okay, so that's going to be the basic idea, the basic syntax. We will touch on that here. And again, with the deep programming language, it does not allow multiple class inheritance. We can use multiple interfaces, which we'll talk about interfaces in an upcoming lesson. So make sure you're subscribed or following along in the playlist to check that out here. And this is largely because a lot of programming languages that have had multiple inheritance, it can cause some complication, or it's tempting to add that sort of complication. Again, multiple inheritance is just another tool that has to be used wisely. But D and other languages like Java, for instance, do not allow multiple inheritance. I believe C# doesn't as well, but you do get to do multiple inheritance sort of through multiple interfaces. And again, we'll talk about interfaces later. So anyways, with that said, let's go ahead and just start off with a simple example here by sort of recreating our classes here, or a little inheritance hierarchy rather. So we'll just kind of model off of this example here. Let's do it with something more reasonable though. Let's do the classic, like create an animal class here, and we'll give it some function here. I'm just going to make it like make noise, something like that here. And let's write out the fully qualified name, animal, the class name, and the function name here, just so we can kind of keep track of what's being called from each different type here. So I'll go ahead and create animal. Let's just go ahead and say, and I need to, again, make sure that I allocate using the new keyword animal here so that we have space for this. Again, if you call a function here without doing the allocation, so again, you might run into this. Again, depending on where you are in your D career, you'll run into this, right? You'll get a segmentation fault because we do need to, in fact, allocate here. Oops, there we are. And then we'll see that our function indeed is called here, no problem. So that's our member function here that belongs to this animal class here. Now, the idea, again, is this is going to serve as our superclass, or sometimes the base is what we call it here. And let's go ahead and derive a new class. So this will be our subclass, or derived class or derived type here. And let's just go ahead and create cat here. That will be derived from animal. So cat is a new type of animal. So how to also say this, and you also see this, is cat is a type of animal. Okay, so it has that sort of is a relationship. Okay, so this is just your standard. Again, this might be review for some of you folks here that we're just sort of creating this hierarchy here where we have animal at the top, and derived from it is cat here, and we can have other types, you know, derived from here. We could create, you know, dog, and so on. Okay, and they're all a type of animal here. And again, this gives us the advantage here that we can use polymorphism or have anything that is a type of animal declared or put into a collection. Okay, so we'll go ahead and do that here. But let's go ahead and just start with this here, just to again show how this works here. And this time, let's say I have an animal C, and I'm going to say it's a new type of cat here. C, I'm going to call make noise. And then let's go ahead and run this program, and you can see that this works here. Okay, so I've taken animal, and that's my superclass, and I've instantiated a new cat. So anything that is a type of animal, I can instantiate from here. So that's kind of a nice thing here because, again, we have that is a relationship here. And then it's going to call the appropriate function here. Now, what we can do is say, well, for cats, they should make the cat noise here, right? They should maybe meow or something. So let's go ahead and try as a first take here to do cat goes, meow, something like that here. And I'll go ahead and make this a little bit larger just so we can see all the code here. Let's go ahead and give this a try. Let's see if this compiles here. Make sure I save. And you're going to see this error message here, as expected here. It says, cannot implicitly override base class method. Okay, so from our main module here, animal make noise. So that's from here with this cat here. And it says we need to add the override attribute. Okay, so again, D is being precise. Some languages let you get away with this, but I actually like that that in D we have to be explicit, but we need to add this override attribute here. So we're going to add override, and you add it to the front of the function, not the back. And let's go ahead and see that. Well, let's see it work first. Okay, so now it compiles properly and says, okay, animal, right? That's the sort of superclass or the base here. And then we can instantiate from it or allocate from it any new type here, new cat. And then because this thing is of type cat, we've said, new cat, allocate the memory for a cat thing here. So we're going to call the cat member functions here. Now we're going to dive a little bit into the mechanism of how this works, known as a virtual table, and discover that these are virtual member functions here in the next lesson, right? We'll draw that out in Tarkir time here. But hopefully this makes enough sense here to say that we have an animal in both cases here. And depending on how I allocate it, so if I allocate it as animal, it'll call the animal make noise. And if I allocate it as a cat, it'll call the cat make noise here. But because we have two functions named the same thing in this inheritance hierarchy, right? Here we have animal, and it would have its own sort of, I'll just draw off to the side here, make noise. And cat has off to its side, make noise somewhere. I need to know which is the correct one to call. And if I've instantiated it as a cat, I want to use all the, cat-related functions here. Okay, so that is the idea there. Now let's go ahead and do one thing here. Let's go ahead and take a look at that override attribute here. And to find that, we can go again to the language reference or find it on the left side here. And it's going to be under attributes here. And we can search for it, or just, I highlighted it here, override. Let's click on it. And it's going to lead us to virtual functions, which we're going to talk about again more in depth next time. But this is basically, again, giving us the rules. So saying if I have some class here and I derive a new type here, B for instance, derived from A, and I have the same function, I need to override it here. Okay, just so this helps the compiler know exactly which function to call here. Okay, now we can be a little bit more precise though, if we want, right? When we're just saying, C make noise, we have to make a decision as to which one we make here. But we can still provide, so we can still help compiler figure out any valid make noise function, and let's call it member function, and I'll put here virtual member function in parentheses by providing the full name here. Okay, so I could do c.animal.make noise. Okay, and if I run that, that'll actually call on our cat object, c.animal make noise here. Okay, it's calling it from our superclass here, which is fine. There's no problem with that. And you're being very, explicit with it, but typically speaking, when I override some member function, for instance, it's because I want to change the behavior of how a cat is doing some functionality. But maybe there's something interesting going on in make noise. Maybe it's instantiating or setting up the object in sort of interesting way here. So again, you still have that capability. So I just want you to be aware of how the compiler is sort of resolving which function to call. Okay. Okay. So with that said, let's go ahead and just say, let's add another function here called, let's just call it like move or something like that. And I'll just say the animal moved. Okay, and that might be something that you want, again, all, animals to be able to do here. So you can have this function here. Let's go ahead and just call it c.move. Again, demonstrating that my cat can move. And you'll see, again, that's a valid call here, okay? And in fact, you might want to make it sort of illegal to override this. So you can declare it as final, for instance. And let's go ahead and run it just so you can see that it works here. And if I try to override something that is final, so my move function here, let's go ahead and try to run this. It is going to give me some sort of error here, right? It's going to say you cannot override final here. Because again, we're saying, hey, that's the final thing. We don't want anything else that's derived or is a type of animal to be able to change that behavior. Now we'll see final show up in other things like interfaces and abstract classes later on. And it also has a sort of nice optimization purpose of resolving sort of some of the performance things that can come up with virtual functions. So again, it's a useful thing to know about. But in particular today, since we're just talking about inheritance hierarchies, it's just useful to know that you can stop, various member functions from being overridden if that's important. And what I mean by important, it's you're signaling sort of as a contract to anybody else who's doing something or deriving a new type of animal from overriding this member function here. Okay. Alrighty. So the last things that I want to show you here, now that we've gone over override, final, and shown an example of inheritance, and of course we've covered things like constructors and destructors and how to do copies of classes in the previous videos, but I want to show you again some of the utility here. Again, I've shown you how you could just have animal and declare either a new cat or a new animal itself, which is sort of the base type here. But again, the utility comes when you have collections for these sorts of things here. Like, let's say I just want an animal array here. I'm just going to call it animals. And let's go ahead and append to our animals array. Let's go ahead and add in A. And let's go ahead and add in C here. So I'm just appending these two to this collection here. And because this is a reference type, this is a pretty fast operation to do here. And I'm just going to say for each of our animal and animals, let's just grab all of our animals and have them, make a noise here. And let's go ahead and give this a run here. Oops, I got to get rid of my final here. Or rather this here. Let's go ahead and comment that out and say cannot override final member functions. There we are. Member functions. All right. And then back to what we're focusing on here. Just the advantage of, I mean, this is the real reason why you want to be able to have inheritance in my mind. It's so that you can have some generic sort of type here, or base type here, where you can add things into a collection. Okay. And then whether they're just animals or cats or dogs or whatever other types that you derive here, no problem. You can call the right function with the right behaviors here. So if we go ahead and give this a run here, we can see we've got our animal make noise and cat goes meow, which is corresponding to the two animals that we've added into this collection here. And if you want just a little bit of exercise to review some of the things that we've been talking about in this series, you can go ahead and check, the address of A and C and see that they match up here because they're, again, the reference types here. But that's just a little bit of a side here. Okay, so that should give us a pretty good idea of how inheritance works. And there's yet just a little bit more here. In this particular hierarchy that I drew, I have to amend this diagram as we circle back to the sort of top of the video here. And there's actually one sort of thing at the very top here. Again, it's come up, I think, a few times here. That says object at the top there. If you remember, we opened that at the top here. And again, all D class objects inherit from object. So you get some of these functions like toString, toHash. You get an op compare, op equals. And again, these are going to be things that you'll want to, for instance, override for your particular class. So you're not, relying on whatever object is doing here. Okay. So you can kind of keep that in mind here. So I just want to go ahead and show you that even though you're not going to see a toString function here, let's go ahead and just write out a.toString. Here we are. And let's go ahead and write out c.toString as well. And these come from object, from which all classes are derived from. Okay, so in theory, you could have, and there you can see the names here. So main is the module. That's the name of my file. By default, the module name is going to be the file name. We'll talk about modules later. But I get animal and cat here. Okay, so just something to be aware of if you want to change those behaviors from object, that is available here. And it might be worth perusing, as you get into the more advanced D stuff later on, or maybe if you're already an expert, to look at this file here a little bit. Some folks, will really, implement their own versions of these and kind of override the behaviors, which is kind of interesting. That's something I'm looking into as well. And there might be different reasons to do that depending on what sort of like platforms you're working on. But anyways, that's a little bit of an aside here, but just wanted to show you. So anyways, folks, with that said, just again, as a quick review here, we looked at inheritance, so how to derive a new type from a sort of base or superclass, but recall that object is at the top of that hierarchy. We looked at adding member functions here, but these are really something known as virtual functions, so we're going to go ahead and talk about those later. We can override the explicit behaviors here, which is usually what we want to do if from our subclass we are changing the behavior from our superclass, as shown here. And we can, at any point, mark a member function as final if we don't want it to be overridden later on in the hierarchy, and that can be a good thing just as a contract to the user so they know that, hey, we shouldn't touch this, or at least you should think about not changing this. And otherwise, this also makes it less virtual, so to speak here, which can be a benefit for performance. All right, so we looked at quite a bit here in this lesson, and again, then saw the advantage of having this sort of from our base type, being able to create collections and then add things, whether they're just animals or cats here, and then be able to work with those collections and just have it do the right thing. And this is a super nice thing that you can do. It's one of the nice advantages of object-oriented programming. And again, you can think about how to do this if you didn't have objects. For instance, you would probably have like a union of structs or something like this to sort of implement your own sort of polymorphic behavior. But again, if you're going to be using classes or are able to, this just makes things really nice and easy to do if you're venturing into classes and the object-oriented side of things. So anyways, with that said, folks, let's go ahead and show you courses.msha.io, which I'm sure you know about, but you can track your progress on all of the D programming lessons here. And there's other courses that you can check out here if they're of interest. But with that said, let me know if you learned something interesting today, if you've done something maybe interesting with object, if you otherwise use these sort of techniques, or otherwise have questions about anything, related to inheritance with classes, feel free to post those below. Anyways, folks, thanks for your time and attention, and I'll look forward to seeing you in the next one.